Imagine meeting a 25-year-old kid who seems to know everything, quotes Shakespeare, solves calculus problems, and even gives sound financial advice. But this knowledge didn't just appear overnight. From the moment they were born, this person absorbed knowledge, first by hearing words, then by recognizing patterns, and eventually understanding complex ideas. But here's a thing to think about. Do they really remember every single lesson, every bedtime story, every math problem they got wrong, every piece of advice from their teachers? No, right? The human brain doesn't work that way. They influence how we think, what we believe, and how we react to new situations. When we make a decision, we don't recall specific information like, oh yes, on June 3rd, 2012, I read a book that told me to do this. No, instead, our minds have generalized knowledge, a collection of everything we've seen, heard, and everything we've experienced into a condensed thing called intuition and reasoning. And that's also how large language models learn. An AI model doesn't remember the specific article it was trained on 5 years ago, but the patterns it learned from reading thousands of such articles. Those patterns shape the responses that it gives. LLMs didn't just wake up one day knowing everything. They were trained on vast amounts of data, making mistakes, adjusting, and learning patterns like we do. And similar to us humans, their knowledge isn't perfect. They make errors and they do have biases, but they also improve over time, just as we do, through education, reflection, and feedback. So, how does an AI go from learning billions of words to generating intelligent responses? Let's break that down now. When a child's learning to speak, they don't memorize a dictionary. Instead, they listen to their parents, absorb common phrases, and gradually understand the rules of the language. They pick up on what sounds natural, what words should go together, and even what tone fits the right situation. Large language models follow the same principle. Only, instead of listening to parents or peers, they listen to massive amounts of texts. LLMs are trained on trillions of words from books, Wikipedia, news articles, and even internet discussion forums like Reddit and Quora. And they don't understand words like we humans do. Instead, while they're processing these trillions of words, they're building patterns in how the words come together and also how, like, what ideas are and how things are structured. Think about how kids learn grammar. A child might say, I go to the park, and then an adult would come and correct them, saying that no, it's I went to the park. Over time, the child refines their language through feedback and repetition, and they don't actually memorize a list of grammar rules in their mind. They just learn what sounds right. AI learns things the same way. During training, the model makes a prediction and then compares them to real world text, gets corrected through optimization techniques, and slowly improves its accuracy, just like a child refining their language skills. Let's say you start a sentence with, the stock market crashed because. Your brain instantly expects something along the lines of because of inflation or because of interest rates spiked. But you don't memorize every sentence you've ever read. You just know which words tend to follow the others based on past experiences. Now, LLMs don't really understand what a stock market is, but they've seen enough texts to predict what comes next with a high probability. Instead of memorizing facts, they learn statistical relationships between words. This is why AI can generate entire documents that feel natural, because it has absorbed patterns from billions of examples. There are different ways to teach a child. Sometimes a teacher might give direct answers, explaining why 2 plus 2 equals 4, or why or how Earth revolves around the sun. And in AI, this is called supervised learning, where the model learns from labeled data, where correct and incorrect answers are provided explicitly. For example, imagine training an AI to recognize animals. It's shown a picture of a cat along with the label cat. After millions of examples, the AI learns what features like whiskers, fur, ears define a particular animal called cat. When it sees a new cat that it's never seen before, it recognizes the patterns and labels it as a cat. But not all learning happens through direct instructions. Think about how a child decides what food they like. They're not given with a list of this is good food and this is bad food. They just experiment. They try mango, they love it. They try Brussels sprouts, maybe not so much. And this is like unsupervised learning, where AI isn't given direct answers, but it's expected to build patterns and recognize things over time. Through unsupervised learning, AI analyzes massive amounts of text and starts analyzing structures. It figures out that Google is related to search engines and that Tesla is linked to electric cars and Bitcoin is mentioned alongside cryptocurrency without anyone explicitly teaching it these relationships. And then there's reinforcement learning, where AI learns through trial and error. Think of it like playing chess for the first time. You don't start with a full strategy. You make moves, you lose, and you learn what works right and what doesn't, and then apply it over your next games to get better at it. AI models trained on reinforcement learning get reward signals when they perform well. AlphaZero, for example, learned to play chess by playing millions of games against itself, discovering strategies even stronger than human grandmasters. And you've probably helped train AI without even realizing it. Every time you give an upvote or a downvote to a ChatGPT response, it uses that feedback to refine future answers. Over time, reinforcement learning helps get rid of bad habits, improve its accuracy, and also avoid biases. And LLMs aren't just passively absorbing knowledge, right? They're actively refining and optimizing their learning, just like we humans improve our skills through practice. Now imagine a child learning to write. At first, their writing would be uneven. Some letters would be too big, some letters would be slanted, some squished, and it wouldn't be perfect. But over time, with corrections from teachers or parents, they adjust. They realize that, oh, my A is too wobbly, let me straighten it out, and things like that. They tweak and improve their writing over time such that eventually their handwriting is polished and looks natural. AI does something very similar too, but instead of adjusting handwriting, it adjusts numbers and probabilities. Every time an AI makes a mistake, whether it's misinterpreting a sentence or making an incorrect prediction, it figures out what went wrong and fine-tunes itself to get better. This is called back-propagation. When an LLM generates a response, it compares it to the correct answer or the expected output, and if there's an error, the model traces back through its layers, identifying which neurons contributed to this mistake and adjusts them accordingly. And the way in which AI knows how much to adjust is another concept which is called gradient descent. Picture a hiker in a mountain in thick fog. They don't exactly know where the lowest valley is, but they do know one rule. Always step in the direction that's going downhill. Step by step, they keep moving lower, adjusting their path until they reach the very bottom. That's what gradient descent does. At first, AI would make a random guess and then gradually adjust step by step with each iteration until it finds the best possible setting where the error is minimized. With each cycle of training, AI refines its responses. Before transformers, AI processed words one at a time in a fixed order. It couldn't look back or connect ideas, which made long responses clunky and inconsistent. But transformers changed everything. Instead of reading word by word, transformers allowed AI to scan an entire paragraph at once, focusing on the most relevant words, just like you do when you're reading. This is called attention mechanism. This is when AI pays attention to certain words more than others. Remember the man you met at the beginning of this video? His knowledge isn't just random facts. It's a network of connected ideas built over the years. AI is able to work the same way due to transformers and attention mechanisms. If you found this part interesting, I've actually made an entire video on transformers and how attention works. If you want to understand what makes AI tick on a deeper level, definitely check this out.